values and other values. In this figure, software also offers options. For example, calculating rooftops or facades of buildings. For example, you have to determine the losing energy amounts, because percentage of, for example, percentage of window, percentage of door, percentage of wall. We have to consider these data. You can search for any building, and you can placement of the photovoltaic panels onto the buildings. You can easily see Bimtaş company, and you can create the air pollution map of Istanbul according to World Health Organization criteria. We have two important advances in these studies. For example, you can see in the figure the main roads. We can make a buffer analysis by using main road by reference main road, and bulk queries also available for finding the buildings. Unfortunately, we have some limitation in these studies. For example, in the Istanbul, we have many landmarks in the LOD 3, and we cannot add these landmarks in the Unity. But we are working on these issues. We are willing to progress this issue, and the lack of knowing the door and window position of the buildings. We necessary to progress this problem. In the discussion and future parts, I mentioned some of these sentences, but I can share with you objective of project is only calculate the potential of solar and on the residential and commercial buildings. Some of the complex, as I mentioned before, some of the complex shaped buildings also excluded because of the difficulty of settings of solar panels, and we also could transform buildings, rooftops, and facades into GIS-based layers where more spatial or temporal analysis could be carried out on the layers, provided it has an integrated spatial database. And the lastly part, conclusion. In this study, we discussed the 3D modeling implementation in estimation of solar energy of buildings in Istanbul city. The project used the game engine to integrate 3D City GML basic buildings for solar receiving simulation, thus making Unity as one of the promising desktop platform for 3D modeling. And we have to progress in higher LOD accurate equation, for example, shadows, sunlight movements, etc. And other man-made feature involvement could be addressed in the future. I can mention about these suggest. This is enough for me, and I want to finish my presentation. My lifestyles, what goes around comes around. Thank you. If you have a question, feel free. Please feel free.
Thank you very much, İsmail. Do you have any question from the audience? No? Okay. Thank you very much. Okay. And now I would like to invite, I think, Dr. Ümit from Marmara University, sorry, Mimar Sinan University from Istanbul.
Thank you. Hello, and welcome again for the session. Today, actually, this is the only presentation that I will give in this this year's GeoAdvances. It's about a web API and web application for dissemination of air quality information in Turkey. It's, for several years, I've been, as most of you here know, I've been working in 3D city modeling, city models, building information models, and all those type of technologies. But in our departments, we have several different people working on several different projects. That yesterday, my PhD student Mehmet has talked about the IoT. Today we are talking about something different, but it's, as the department is informatics, so creating different types of research. So this is about API development application about dissemination of air quality of information in Turkey. So we try to provide means for disseminating the air quality information. Mainly this is historical air quality information to the people who need it, actually, to the software professionals. First, I'd like to introduce my department. I've been in this department for 3 years now. This is Mimar Sinan Finance University Department of Informatics. We run 2 graduate programs in the department. One of them is the old one, but it's called Computer-Aided Art and Design, which is focused on art and design informatics. And the other one is I established a new MSc degree there. It's called Architecture and Urban Informatics. In the degree, we are working on 2 different topics. One of them is building information modeling, the other is 3D city modeling. So if you like to start the degree, then you can choose whatever area that you like to carry on, and you can either be a BIM expert or a 3D.js expert. So this is what we're doing for the last 3 years in Mimar Sinan. We have 2 campuses, so we're in the Bomonti campus. This is very well known for the campus of the university, which we did GeoAdvances last year, actually. Okay, the presentation is prepared by Kemal Şahin, the other author of the paper. It's mainly based on many graphical images. We don't have too much text in the presentation. The problem is real-time and location-based monitoring of air quality in Turkey. Also, we are also looking at how to get the historical data and how to disseminate the historical data as well. So just a brief introduction to the air quality. Air quality is concerned with different pollutants, and it's actually the quality of the air is related with the pollution of the air as well. So it's if the quality is better, the pollution is lower. If the pollution is better, pollution is higher, the quality is lower. So they get inverse proportion between them. So when we're talking about the quality of the air, we're talking also about the pollution of the air. The pollution of the air is caused by pollutants. Actually, there are several formulas of them, like carbon monoxide, carbon dioxide, and so on. These are called the SO2, NO, NO2. These are called, and the particles as well, particles in the air. These are called the primary pollutants that actually makes our air polluted and dirty, which we don't like, which we don't want. And there are several different secondary pollutants as well. So depending on these pollutants, World Health Organization, as the previous presentation you see, my colleague İsmail also mentioned about the air pollution and the indexes of World Health Organization. There's the air quality index that shows us actually how risky it is. The level of, depending on the level of pollutants, the index gives you that you're living in an area that's either a low risk area, moderate risk area, high risk area, or very high risk area. So if the risk level goes up, goes to a very high risk, then you should take, sometimes if it's very high, you should take immediate precautions in the city. Just give very immediate decisions to stop some of the activities in the buildings and city in different parts of the city. Some you have to warn some factories, and you have to stop burning coal or something like that if the risk is very high. But if the risk is moderate or low, so you can plan for long-term actions. So the level of risk is important because you have to plan depending on the risk. You have to sometimes take very active and very fast decisions, and otherwise you have to wait. You can wait, but you have to also take some time and make even decisions to lower the risk. Okay, so firstly, let's come to the data collection. That's something that we didn't do. It's actually done by the Ministry of Environment and Urbanization, which is a public body in Turkey, which is dealing with all the urbanization, buildings, and all the environment issues. So the ministry have had a project actually established several years ago. It's called Hava İzleme. It's like monitoring the air quality. It's a project. So in this project there are 250 built-in all around Turkey. There are 250